All right. Can you hear me okay? Very prompt group. It is my pleasure. I'm Mike Saperstein. It's my pleasure to lead the government affairs team at WIA to welcome you to the WIA Building the AI Future event. And I actually get to welcome the welcomers. So that is my job here today. You'll see me up here a couple of times. But we will start out, first of all, thanking Verizon so much for having us. This is a tremendous facility, and we are very pleased to be here. So thank you for all the hospitality there. A lot of important conversations to hear about today, as you will see very soon. But to give you a glimpse into what all of that's going to be, let me welcome Kathy Pichet. Kathy is the Executive Vice President and Chief Operating Officer at Crown Castle, and also happens to be WIA's board chair. So please welcome Kathy Pichet.
Thanks, welcome. Okay, good afternoon. Can you guys hear me? Yeah. Excellent, thank you. Thanks, Mike, for being the second welcomer. I appreciate it. And good afternoon, everyone. Thanks for joining us today. We have a very important conversation in the afternoon to talk about building network infrastructure and to deliver the AI revolution. It's really an honor to bring us all together as we have leaders from our industry and government to discuss policy and infrastructure foundations that are going to determine, whether the United States leads or follows in the era of artificial intelligence. As we know, AI is not a distant vision, it's here. We're powering predictive healthcare, we're enabling autonomous logistics, and we're reshaping every way each and every sector operates. But with these advances come profound challenges for our communications infrastructure and the industry. We've got to keep pace with the tsunami of the demand on all of our networks. That's because wireless infrastructure is really AI infrastructure. But how much data will AI really consume? How are we going to support connected sensors? All of these are not abstract questions that we hope to answer today. Our nation's largest carriers are predicting double-digit demand over the next 5 years, partly by AI-enabled applications that are going to require low latency, high resiliency, and vast network capacity. To that, we're very excited. Then in a moment, I'm going to introduce Iago Tenorio. Let's all also welcome, it's his 1-year anniversary with Verizon and being in the United States. And he's going to talk to us about how Verizon is planning for the wave of our future network demands. From my view, to stay ahead in America, we must lead on 2 fronts. We must continue to realize the promise of 5G as we lay the groundwork for 6G. They're not separate races. They are 2 stages of the very same competition. And as we know, the nation that wins will unlock new levels of productivity, growth, and security. Winning this race with all of us will require smart, forward-looking infrastructure policy and policies that accelerate deployment, unlock spectrum, and enable innovation at every layer of our networks. That's why we all know today's discussion is so important. Together, we're going to examine how policy, technology, and investment can work together. Thank you again for being part of this vital conversation and for your partnership in shaping the future of the wireless infrastructure and AI. I'll hand it back to Mike, the welcomer, and then we'll have him welcome Iago.
Yeah, sure. Thank you, Kathy.
Thank you.
Let the welcomes continue. So it's my pleasure now to introduce Sean Shahini, who is the CEO and co-founder of Inorsa, who's one of our sponsors today. So thank you, Sean.
Nice to meet you, everyone. Can you hear me? Right, cool. So thank you, Kathy, for that speech. Kathy is one of our really most innovative leaders in our industry, pushing new standards for progress and transformation. So now it's my privilege to introduce today's keynote speaker, an individual whose remarkable career has profoundly influenced how billions of people around the world stay connected. Iago Tenorio serves as Chief Technology Officer and Senior Vice President of Strategy and Technology Enablement at Verizon. In his role, Iago leads Verizon's work in advancing new 5G use cases, works with partners to lead new technology advancement and map out the next generation of technologies that Verizon will bring to customers where they work, live, and play. Prior to joining Verizon, Iago spent more than 25 years at Vodafone, building high-performing teams, and is recognized for his expertise in architecting Vodafone's Open RAN, cloud networking, and network APIs. Him and his team oversaw the network technology-related decisions and defined the company's technology roadmap across mobile and fixed wireless networks. He served as CTO of Vodafone Ireland and Chief Network Officer in the UK, successfully leading Vodafone's network coverage for the 2012 London Olympics. Is widely respected as an innovator and thought leader in the mobile networks, pioneering concepts including single RAN and Open RAN. Yago has invented and patented technologies including a revolutionary smart cell, small cell, and novel location system, and the first cloud-based smartphone. He has deployed several world firsts, including the first 5G non-standalone call and the first 5G commercial smartphone connection. Yago is known for driving innovation throughout the industry during his tenure as chairman of the Telecom Infra Project and chairman of UK startup Line Microsystems. For his contributions to the industry, Yago was recently elected as a fellow of Royal Academy of Engineering in the UK, one of the most prestigious network industry honors across all fields of engineering that very few professionals achieve in their technical careers. So with that, I don't know who Yago is, but.
Thank you very much.
Of course.
Thank you, and good afternoon, everybody. Is my microphone working? Yes? Well, that's a good start. Okay. And I left my notes here in case I forget something, but you know, I don't think that's relevant because Kathy just stole all my thunder. And if that was, in case that wasn't enough, then I had to listen to the introduction you did. I don't know who wrote that. I need to have a word with the people who write the bios. I need a shorter one and more to the point. And some of these things you mentioned, I didn't remember. So I'm humbled and honored. Thank you very much for having me today. I'm really passionate. I came from New Jersey. I live in Jersey City. So instead of Basking Ridge today, I came here. And it's, yes, my first year anniversary today. That's one part that she stole. But it's great. I mean, it's my first day here in this office, which is beautiful and a beautiful environment, and I really love it. And one of the reasons why I came, apart from being new in the company, you tend to say yes when they ask you to speak at events. It's because I'm really passionate about this topic. And I mean, AI is very difficult to overstate in terms of importance. So I'll probably skip that part. And when I look at what Verizon has been doing over the last decade, we've been deploying machine learning first, now AI in nearly all processes. But it's true that the whole thing is scaling now. We produce 70 billion data points per day that feed AI engines that assist us in self-healing, self-organized networks. They assist our technicians in root cause analysis. We deployed to just do a better planning so that we plan our coverage and how we expand our capacity, fitting better with what our customers need. You name it, we deploy everywhere. Of course, that's enabling our customers to do things that they want to do with AI when they want, whatever they want. And that is far more important than what we're doing. We're using it for our own purpose and in our own company. We are enabling companies like ours to use it for their own use cases. You name it, like healthcare was mentioned, manufacturing, public safety, and also in consumer, privately. All of us, every now and then, we use AI. So that drives the economy, society, and the industry. And that's why it's important. And it's very well aligned with the ambition of the administration to make sure that the US leads this race, dominates globally. But what is the currency? How are we going to win this race? Obviously, everybody talks about silicon, and silicon is probably one of the most important pieces, GPUs. Now everybody knows what the GPU is and what it does. That's part of the currency. Now, these little things, they consume a lot of power and they take a lot of cooling. So power, space, and cooling, interestingly, is also part of the currency set. That is where maybe the intersection starts with the wireless carriers, because we do have power, space, and cooling available, and we have it in the places that matter. Where? Close to the customer. Why that matters? because the latency is shorter. What's the latency? As the round trip time. So the time it takes for an information, a packet, or an order to reach the server and come back. The closer you are to the customer, the faster it is the response. So having infrastructure and having power, space, and cooling near to the customer, it matters. The other thing that also matters is the ability to be able to communicate and shift big, vast amount of data through fiber optics between these centers. Why? Because when you use AI, normally you do something that's called inferencing. So you ask a question, and the server or the GPU or the AI infrastructure processes it and infers an answer for you. But almost constantly, all the AI infrastructure is getting updated to the current knowledge, and that's called training. And that implies moving vast amount of data from data centers. The carriers, telco in general, wireless carriers, we act in both places. And you can think of that kind of fiber network that connects the data center as the central nervous system that enables AI. So I couldn't agree more that wireless infrastructure is AI infrastructure. Anyway, how can we win this race? What sort of policy we need? I would say we're looking for something that is risk-based, a sliding scale of obligations that are tied to the harm, potential harm that is caused. That would be one aspect. Another aspect would be a policy that differentiates the role that different players are playing. In our case, it's very clear. It's not the same to be the developer of the AI than to be the deployer of the AI. And you shouldn't be having the same obligation. The same when we think of consistent horizontal policies that, for instance, not necessarily make everything critical on a critical network infrastructure. So just because you are critical network infrastructure, it doesn't mean that your obligations to AI should be critical. If that's all well and good, I would probably stop here. So that's it. I think it's clear. That's the arms race, power, space, cooling, GPUs, communications, here and there, policy, obligations, depending on your role, done. Not exactly. So this is where the arms race is today. But someone once told me, you have to skate where the puck is going, not where the puck is. This is where the puck is, but where is it going? So I think we are about to witness another iPhone moment. You remember? Some 10, 12 years ago, probably more, time flies. When the Jesus Christ. I'm closer to retirement now. 18 years ago, the iPhone happened, and it changed everything. Everything in how consumers access the internet, everything, new businesses, new excuse me, new services, new economies. It was when the smartphone started. We're about to see a similar moment that is driven by what? A change on the interface, which is the same that the smartphone did. It changed the way we interface with the internet. Well, a new change is coming. For the last probably 3 decades, for as long as internet existed, we've been looking at internet through a rectangle. And that rectangle of variable dimensions, depth and width and height, and variable colors from green phosphorus to variable definition, but always a rectangle. That is going to change, and it's going to change soon. Which, by the way, personally, I can't wait, because I am just done with walking on the street or trying to run. I'm a runner. I try to run, and I bump into people with their nose on their phone all the time. So I think we need a user interface that is more embedded with our environment, with our real world, that augment reality, not substitute reality, that brings you closer to people. I think potentially is a very good thing. And it's going to drive change. Where is it coming? It's going to come from smaller, wearable, sensing devices. Now, it's debatable if it's going to be glasses, if it's going to be something else. Honestly, I don't know. But what I don't think is debatable is that it's coming and it's going to happen. Now, this is very relevant for AI. I think it's particularly relevant for AI. Why? Because all this sensing and all these wearables can be used to provide context to AI on an always-on mode. So think of it, normally the use you make of AI today is transactional in that you ask a question and the question is answered based on the information that you have already provided to your agent of choice. The more information you provide and the more context you provide, normally the better the answer. Well, that's going to change. You're going to have wearables and sensors that sense your environment. They listen to everything you can listen to. They actually listen to more things that you listen to because they actually listen. They can see things that you can't see. I saw a demo once. It was very cool, and the artificial intelligence agent could actually answer questions like, what is this algorithm in the whiteboard doing, and things super advanced. But the one thing really impressed me is when the person conducting the demo said, I think I forgot my keys somewhere. And the AI said, yes, you left them on your desk. I saw them 15 minutes ago. That's what's coming. So what's coming is, instead of my notes that I have here that I wrote on the train from Newark to Washington, without me asking, my AI agent will instruct me probably through some, I don't know, if it's classes, the speakers, or maybe it will send me a briefing written with how I should plan this keynote today. It will not be like what you may get from Gemini or ChatGPT if you ask, which is a pretty standard internet-based briefing. It'll be based on everything I know or everything I ever knew and I forgot, but it didn't. And it'll be based on my experience, my opinions, because it's listening to everything I say and seeing everything that goes around. Is this scary? But it can be liberating. And if you think about it, and if you think of the power that this is going to have, I think it's undeniable that it will boost society, economy, change. It'll drive new business, and it'll drive the industry, I think, on an unprecedented manner. Now, why is this all relevant to policy? Well, if you think of the architecture for a second, these devices that are sensing everything that goes on around you, where are they going to process all that information? There's one school of thought that says, well, on your smartphone. Like, your wearables will connect to your smartphone. It'll have a mini GPU and, it'll take care of that. That's possible. However, the level of sophistication that you can run on a smartphone like this, and this is almost like the Moore's law adapted to AI, is 18 months behind what you can do if you go to a proper data center. So if you can send all your information to a proper data center, kind of completely racked up with GPUs, what you get is 18 months more sophisticated than what your smartphone can do. And that is not going to change anytime soon. Things develop, but that gap is going to remain. So we can choose being a nation with an infrastructure that takes all that information and processes it where it should on a data center with state-of-the-art CPUs, or we can choose to be 18 months behind. Now, what it takes to send all that information to the data center. So that's an interesting challenge. So first, those wearables, if we want them to connect with cellular connectivity, they're going to be limited in battery power, in thermal dissipation, and in many other things that 6G should take care of. And this is very important because you may think, well, first you may think why we're talking about 6G. If you think that, you're wrong, because we need to decide what 6G is going to be now. And we only have 5 years to make it happen. Second, you may think it's going to be, like it's happened before, about more speed. So instead of gigabit per second, let's talk about terabit per second. Well, yes, I think if we just leave it to their own devices, it'll be like that. But that's not going to actually serve anybody's needs, because no one needs more than gigabit per second on your mobile. So I don't think that's what it should be. What it should be is a technology that relieves the device from constraints like those ones I mentioned, so that they make possible cellular connectivity on ultra thin, super small, super efficient sensors, wearables. The second thing that 6G is going to do is to turn the network and the devices onto sensors themselves. So if you ever ridden a Tesla, on the night screen, you can see a representation of the vehicles around your car, right? And even pedestrians when they cross. And the way that's done is with some millimeter wave sensing devices that are installed around the car. Now imagine that instead of those devices that are only for sensing, the whole network, every base station, and every mobile can do the same function. And aggregated provides you with almost like a digital twin version of reality in real time and in a very accurate manner. That has very interesting ramifications and applications. And of course, one of them is national security. But the true challenge is going to still be how we take all that data and we send it to the data center. Even if we have 6G and it's sensing the world and it's allowing, small wearable devices to perform, the whole 3GPP, the whole cellular technology since data was invented, has been biased towards the downlink. Because the way we use internet is massively biased in that direction. So as of today, normally you have 9 times more downlink traffic than uplink. Now, what I just said about AI is going to reverse that bias. And suddenly it's going to put all the burden on the uplink. 6G is going to come to solve that too, and we need to drive 6G to solve that problem. Now, what does have to do with policy? Spectrum. We just saw the pipeline of 800 megahertz that the one big beautiful bill brought, and that is a super important step in the right direction. That is what the cellular industry needs in this country to make sure that 5G can continue, can make things like what I'm talking about that's going to hit the market in the next year, next 2 years, the early versions of everything I'm talking about is going to come. This spectrum is going to take us probably to the beginning of the next decade. But this spectrum is not going to take us to 6G. Why? Because for everything I just said, you're going to need channels, probably of about 400 meg of bandwidth. So just visualize that as super large, much larger than 5G, contiguous blocks of a spectrum in bands that still propagate well enough to make coverage reach everywhere. We definitely going in the right direction, but if we have to skate where the puck is going, we need to continue this work. We need to make sure that we have line of sight with large contiguous blocks of spectrum on bands that propagate well enough. And we must not forget that other regions have line of sight with solutions like that. Either we can talk about Europe, Asia, or China in particular. They already have a plan. So the future may be scary. I think it's exciting. I think it's going to drive economy like never before. I think this is too important to skip it. And we're going to keep building the most intelligent and the best networks to connect customers, consumers, and enterprises with AI in the right place, with a favorable policy on spectrum. We will make sure that America not only leads, but dominates. Thank you very much.
Thank you. I've heard AI, I've heard infrastructure, national security, network implementation, we would almost do 2 hours without tackle. Oh snap, we got it. Here we go. Let's get into it now. Let's get into our next panel, led by Ian Gillett, who is WIA's Senior Technical and Research Advisor. The next panel is AI in the network and on the network. How AI is impacting the design. After that panel, also talk about all the policy. A lot of good discussion, followed up by Adam Cassidy and okay. Okay.
Thank you, Mackenzie. Okay, my name is Ian Gillett. I'm Senior Technical Research Advisor, WIA. That sounds good, doesn't it? So we've got a panel here, technology. I like things prepared. I'm an engineer, so I like precision and things. Tony and I have many discussions about cars like this. Tony has time limits. We actually had a call about this session as well. So what we're going to do is we want to take the technical aspects of AI, infrastructure, etc. And the way to think about this is AI is both in the network and on the network. Okay, so it is on the network in terms of consumers, y'all, using ChatGPT, Perplexity, Copilot, etc., and imposing traffic strain, however you want to look at it, on the network. Okay, so Yago talked about uplink, downlink changes, for example. But one of the things, just think about this, if you've ever been on ChatGPT and played with video and imaging and saying, hey, give me an image that does this. Well, now change that image, add this, remove this, make the sky blue, etc., etc. Every time you do that, the cloud, the data center is processing that image and sending it back down to you, right? But what if you take a photo with your phone, upload it and say, change this? Now you're sending the traffic up. And so we're imposing new requirements on the network. Obviously there's latency requirements, etc. So that's on the network. The in the network is how we use AI within wireless infrastructure to improve the performance, manage the network, etc. So which tools do we use? How do we design networks? How do we build networks, etc.? And that's what we really want to talk about today. So we'll talk about it from both aspects. So what I'm going to do first is Tony, Akil, and Jonathan. I'm going to, and by the way, we have the order. They're allowed to speak on this as well. I mean, it's, yeah.
These chairs are shot.
Yeah. Yeah. See, I have no water here, you see. So you do? Okay. There's codes for if they speak too long. There's things I do. So what I want to do is, first thing is really easy. Who are you? What do you do? What does your company do? And basically, why are you here? So Tony, you go first. You got a minute. Go.
These
If
are
you turn it
working.
on, apparently.
It's on, but hello.
There you go.
Tony Sabatino. I'm with Diamond Communications. I'm here. I'm part of the ITC, and I've been in this industry since well into the 90s. Started with 1G, then 2G, then 3, then 4, 5, and 6, wherever. Hopefully 6, I can get to it. But Diamond, we're an infrastructure company, a tower company, and we have a bunch of other pieces. We do indoor, outdoor, and I'm happy to be here. My job is to ensure that I understand technology so we can serve our customers better. And so I'm a past CTO of companies like Sprint and other groups like that. So that's under a minute you owe me.
Okay. It's going to be like this all afternoon.
It is.
Akhil.
Thanks, Ian. Akhil Gokul, I head technology for Americas at Ericsson. In my role, I look at aligning technology requirements for this market area, essentially addressing the dynamic nature, and also the strategic investments and directions that we need to go with 5G and 6G, and basically cater to our operator community, enterprise community, and the federal community. In the US, we cater to about 25,000 sites, running about 60% of the traffic on Ericsson network. Very committed in terms of what we are doing in the US market. We do manufacturing. The first and the largest 5G manufacturing site is actually in our neighborhood in Texas. And also we have about 12 R&D centers. So very much looking forward to the inflection of AI, cloud, and 5G, and looking forward to this discussion.
Are you based in Plano?
I'm based in Plano, Texas. Yeah, that's where Ericsson is headquartered for this market.
Yeah. Plano was the first place I ever came to in the US. Straight off the boat.
You cannot not love the weather there.
Jonathan.
Good afternoon, everyone. Thank you, WI, for allowing Airwaves to be up here in a beautiful day in our nation's capital. I am Jonathan Lester, the Senior Vice President of Client Solutions and Technology at Airwaves. That is a mouthful for product marketing, sales support, and technology. So I help bridge the gap from our commercial office to our network and engineering operations. And at Airwaves, we make wireless simple. So if your phone does not work inside a building, we solve that for you. We deploy, own, operate, and deploy long-term partnerships with building owners. So we operate fiber deep networks inside buildings, primarily commercial real estate and healthcare. And then we layer on cellular and advanced technologies beyond that. We are based out of Charlotte, North Carolina, and that's all I got, under a minute.
Okay, good. All right, so Akhil, you get first on this one. Let's talk about that on the network question. So how is AI impacting the demand for networks and connectivity? What do you see from usage? You've got a bunch of networks, you've got base stations sitting out there. So what are you seeing today that AI is doing to the network, the impact it's having?
No, if you look at what's driving the AI demand on the network, right? What is the kind of application ecosystem? You almost think about it in three lenses. What's driving from a consumer point of view? The usage that's coming from increase in the chatter because you're using chat GPT, more bidirectional kind of usage. If you take an example of how search was happening in the past versus search is happening now, search is much more immersive, right? You don't necessarily go to chat GPT for just one question. You have follow-up questions. You're very much immersive. So that's one behavior that we're seeing that's changing the pattern. Is it changing the pattern and the dynamic as such today? Not so, but it's giving us leading indicators as where that behavior might go. The second thing that's very interesting is the prevalence and maybe more the rise of video analytics, the video side of the house, where it's not only streaming video from a downlink point of view, but towards uplink. We see more of that with applications where the user has the capability to edit devices or edit images, or edit even video and live streams. So that we see is also changing the parameter. The third one is where we see a scenario where when it comes to the consumers, Yago talked about these plethora of wearables that we will have. We will look at multiple scenarios of data coming into the network. So from a consumer point of view, we're seeing that change. Is it changing the traffic dynamic today? No, but they're showing leading indicators of how we are moving more towards video heavy. We are moving more towards uplink and things of that nature. If you change gears on the enterprise, here it's very interesting. It's all about agentic AI and agents doing the work. And you can almost think about these agents not sleeping, right? They don't take breaks. So they're always connected and an always functional work. So the ambient information that comes from the field is very prominent, and we are seeing some early use cases of that. And finally, if I look at industries, there is industries like healthcare, where the combination of private networks with edge, we're actually seeing AI applications running on them. Smart manufacturing is a good example where you are not only using it for monitoring, but predictive maintenance, for a digital twin, and essentially looking at simulations per se.
Okay, good. So Jonathan, you've got the in-building stuff, and I know you've got a lot of healthcare. So what do you see from the in-building? Are you seeing a difference in traffic these days?
Yeah, I mean, for in-building wireless networks, we all know data demands are every day just going up, right? So we want to ensure that our customers and clients are set up to be building ready for the data demand and the data boom that's just going to continually increase. We've not yet seen a disruptive drive in data consumption that is changing the way in-building wireless networks are necessarily structured or designed, or air quotes future-proof, if there's such a thing. So again, it's fiber deep throughout the building, especially in healthcare. We do not necessarily focus on industrial applications for industrial IoT type stuff, but healthcare, for how it matters to airwaves, is really where we see a level of AI disruption coming for an in-building cellular network specifically to be able to handle and drive all of those technologies, right? We talked about wearables earlier, med tech devices. They're starting to catch up. And if AI is any indication of the pace and the leap that's happening, we're going to blink and robots are going to be running around the hospitals doing surgery, all that good stuff. So we want to enable our healthcare customers to be ready for that. Again, we're not deploying 100 gig circuits for transport into buildings today, right? It's scalable. It's being able to jump off of that base infrastructure platform so that you're not having to rip and replace everything in your building or your hospital.
Okay, so when you go to a customer and you're talking about improving connectivity in the building, are they bringing up AI immediately, or is it a later discussion, or do you bring it up with them?
Great question. I can hear our chief revenue officer in the back of my head right now, so I got to be very careful with what I say. Kidding, and our chief legal's back there. So he told me it depends is a perfectly good answer. I didn't mean to say that out loud. I'm sorry. So yes,
David, there's a phone call for you outside the room.
We honestly, we let the customer kind of bring that up. Again, wireless is complicated enough in and of itself, right? So our value prop is, like I said, we make wireless simple. So if clients have AI-driven conversation out the gate, we're prepared and ready for that, right? And like we talked about and heard from Verizon, right? It really comes down to that licensed spectrum capability, the option to grow your spectrum needs within your building over time.
Okay. All right. So I've got a question for you, because I didn't bring up 5G and robot surgery and rural, right? Jonathan did. So who wants robot surgery? Who wants to go first? Wow.
I would just like to point out that it's Airwaves people that raised their hand and only Airwaves people that raised their hand.
And one of them had surgery a few weeks ago. All right.
I won't even ride in a Waymo, so.
Tony, your perspective, what are you seeing impact on the network?
First thing is that when we build DAS systems, ODAS, IDAS, and all, we really don't control the capacity. All we do is make it available. We move RF for the wireless carriers. Signal sources driven by AT&T, Verizon, T-Mobile. If you were to ask me or anybody here that controls a DAS network, we have no idea what's being done on the network. What we do know is that we have to be ready for the different levels. And what I call is the new massive level of spectrum area that we just talked about. That's what's going to drive the capabilities that we have that's coming in with AI and the need for bandwidth, right? Today, the killer app in AI is still AI assistance, ChatGPT. Mm-hmm. We're seeing some uptake on the uplink on networks, because I do operate a network outside of Diamond.
Right.
And but today it's not killing us, right? What's getting killed is the data centers, right? And so we have to be ready for it. But from the perspective of how AI is going to drive it, think about this. If you've got a person doing basketball, right, and she's going to go from one end of the court to the other, how many bytes do you think it takes to control that in the 5 levels of the motor skills from human to mechanical? Well, I'll tell you, 14 billion bytes to do those functions. And most of it is visual. The visual pieces are there. So if you dissect the visual motor skills and all that, if we start doing this robotic implementation, if you listen to Musk, what's the hardest thing to put on a robot? It's the hand. 26 intermodal models. The hand is the hardest thing to duplicate. And if you think about all the compute has to be for a 10-second basketball thing to drive that, just imagine the data it's got to take to go ahead and drive that. So I'm excited it's coming, but right now we're just getting an early taste, as you mentioned earlier. It's an early taste, but we're really not seeing the data yet. The data centers are.
Okay, good. All right, Jonathan, you're up on the next one. How do you see the AI demand impacting the design in the next few years? What are you going to be changing that you're not necessarily doing today, but what is it you're going to start doing? Because as Tony says, this is coming.
Yeah, if it's not already here, right? I think what's most critical as a part of an equation or a three-legged stool, the wireless carriers, right? They are very important to where the data demands are going. So staying in sync with their, as you move from the macro indoors, what are their spectrum needs and what is the spectrum diversity offered for each carrier, being able to support that. We have to also manage the density of network infrastructure that we deploy so that we're cost effective for our clients as well too. So we can't just go and quadruple everything and expect people to be happy about that. So it's really staying in sync with the carriers, understanding where the capacity needs that tie back to the license spectrum criticality and just staying in sync with that. So right now, C-band is a hot topic. It's not necessarily a ubiquitous coverage play yet indoors, but as spectrum needs grow, it certainly will be. So we're starting to prepare and stay in sync with the carriers on 2.5 C-band, all the larger continuous chunks of spectrum that we talked about earlier.
Okay. Is there a particular area of concern? Uplink, uplink, downlink's been mentioned. Latency a little bit. Is latency a bigger problem than uplink, downlink? Or?
Yeah. I mean, and from our product set, right, it's really more of an infrastructure platform that we offer. As you talk about smart and advanced networks, multi-access edge compute has yet to really make its way on premise. For healthcare, commercial real estate, and others. I think that's going to be critical if latency is the topic of discussion. And again, we enable building owners to be ready for that. Not tomorrow if that's not the need, but a year from now, 10 years from now, whatever it may be. But yes, it's moving to the edge.
Okay, Tony, what are we going to start changing next? You said.
Yeah. Well, I think actually Jonathan raises a good point. The workhorse for 5G and these evolutions of these AI driving applications for high utilization is going to be in that C-band, your T-Mobile 2.5 with the C-band capability. And as we'll tail in, there's again a discussion on spectrum. We talk about CBRS and, I have a personal opinion. I think it's a failed experiment. I think if you look at from the DoD spectrum that AT&T has, and you go all the way up to the 4.2, which is coming as part of the big, beautiful bill in the 3.8 to 4.2, that's 700 megahertz of spectrum. That's a pretty good chunk if you combine it all. That's what we need. So when you heard the discussion earlier about a wide bandwidth of spectrum to go ahead and get the utilization and capability, you need this contiguous wide band of spectrum to drive that. Well, that's a start, right? Getting through it. What we're finding in networks is, as you look through these capabilities of networks, it's really the idea of a lot of these indoor systems don't even have C-band or 2.5 today, and it's being ready for those and adapting them. And that's not just a simple add it. There's other things that have to be done because you have a higher frequency, lower capability. So there's going to be a lot more investment in those as carriers bring it in. Last thing is carriers aren't paying for it anymore. It's all clear. You can see it every time in their public reports. They're not paying for in-building solutions like they used to. If it's not an NFL stadium, it's going to be bought by the hospital or somebody else for most cases.
Yeah. And I have to tell you, I was at an NFL stadium a couple of weeks ago, 49ers, and I was sending photos to several people in this room, and I had no problem sending, receiving. It was pretty good. I was pretty impressed.
Yep.
Because then I was somewhere else and I had absolutely no coverage whatsoever, and I can't remember where it was now. Oh, it was the airport. One of them I needed it, and one of them I didn't need it. So, Akil, what are you gonna start doing with those networks?
Yeah.
And obviously you've got the hardware, you've got radios, right? So what's the next changes in radios you anticipate to deal with this increased demand?
And I think if you look at the design construct, stadiums are a good example, right? Because you can use them to really figure out how extreme the network needs to behave and then plan accordingly. So if you talk about radios, it's really making sure that we have the capability with a larger spectrum coverage, so you can take in both the uplink and the downlink traffic, and essentially think about concepts like duplex, like full duplex. But if I go back to the design constraints and design considerations that we need to keep in mind, uplink is definitely the most that we need to plan from a hardware point of view, from a software point of view. And even the lowest conservative estimates is like 20% uptake just because of AI application. And that CAGR over a 5-year period is almost like 98%, right? So even the most conservative estimates says that if you see that kind of projections, between 28 or 29, the current capacity will already be saturated. So everything that we do from a design constraint point of view is all like uplink first, because that paradigm in traffic, which is very downlink heavy now, is going to shift. Now, when it's going to shift and how it's going to shift, it's a little bit of TBD, but we need to prepare for that paradigm shift. The second thing is there's more need for computational capabilities towards the edge. We see that not only for bringing applications from our perspective like UPFs or distributed edge, but more can we look at things like sensing, where you have to have the fusion of different sensors, and can that be done at the edge? Data, your AI is going to be only as good as the quality of the data and the single source of truth. So a lot of focus on bringing that data together where it's not garbage in, garbage out, right? So curating that data and housing it in a single place. And finally, we in Ericsson, we talk a lot about differentiated connectivity. AI applications drive very different needs than you and me. So should we think about a super lane for just AI applications, so that way we can balance out the need for an always an application towards something that's very cyclical, where we are waking up in the morning and sleeping in the night, right? So these are, I would say, the fundamentals, but all of them are being driven from how the device penetration will happen.
So that last point is interesting. So do you see a slice for AI? Or are you saying AI, I'm sorry, you can only work between 10 and 6 a.m.?
We absolutely see both, right? We see the need for slice in certain scenarios where you want to guarantee those SLAs. And when you know that it's not about the predictability of traffic, which is more, I would say, sustained as opposed to the cyclical nature, we definitely want to provide a slide. We want to guarantee it, and we want to make sure that the network and the infrastructure can cater to that slice. So think about a use case where your SLAs are being met in a consistent basis as opposed to utilizing uptime and downtime, right? On the other side, we want to actually be more effective in the way we want to use the downtime. So today we use technologies like sleeping, making the radio take micro sleeps, or shutting down certain part of the network. Can we actually use that from a computational capability and the network capability when you have these agents running? So can we be a little bit more strategic in how we plan for AI applications to leverage the network as well?
Okay, I'm going to steal that because it's really good. I'm going to put it in a blog. It'll have my name on it. But I'll credit you. I'll credit you. Okay? Yeah.
Can I?
Or are you actually going to mention his name?
No, I'll mention his name. I'm going to pay him.
Can I add real quick just onto that? Just in terms of the network slicing concept and all that, again, with policy and spectrum, focus topics today, that is where those larger swaths of spectrum are going to be critically important. And the wireless carriers in the 4G to 5G transition, I mean, that's happening right now. It has been for several years. But each wireless carrier has a strategic initiative for network slicing opportunities, obviously in conjunction with Ericsson and the other RAN vendors. But we're starting to see that more and more in carrier conversations every day.
Good. All right, Tony, you got the next one. Let's switch gears now. Okay. We talked about AI on the network. Let's talk about it in it, right? So what is it that you're doing today? The design, build, operate the networks, right? So it could be designing them. It could be scheduling work crews to go out to a tower, whatever it is.
Yeah.
What are you doing today that uses AI? I assume there's more coming, but any good examples?
Well, first, as you look at a network, you have to drive it into 4 components, right? You have the design, the deployment, the optimization, and the maintenance of it, right? And so what's really, all the carriers have announced what they're doing here, and I have some firsthand knowledge of what's going on right now. And if you look at what's going on with the AI engines that are being built in these systems, and they've built their own AI engines before you guys come out with your AI RAN. Finally, it's coming. But Nokia and Ericsson are on the AI RAN alliance, so they're very informed on this. But what's important is think about what one carrier is doing is the United States is built into a hex system. Think of a honeycomb that's spaced across the whole United States. And each day, you heard the number of billions of points that's given on the network each day. Those systems go back and determine a geofence for you, and you. Everybody has their own individual system of performance, and they know how you're performing. So customer care agents start reacting to that, but also the network is being planned and designed for growth and capacity based on what they're seeing. Poor RSRP, poor SINAR, poor RSRQ, quality of service, all those things are being driven. I used to have thousands of engineers across the country doing these analytics each day, wake up in the morning, get that data. Today, they're using systems where that information is in front of them. And as we start looking into the AI RAN and these energetic type systems, they actually don't go back and have the human energetic interface, but actually start making the decisions through these large language models. This is really compelling with smart beam antennas, forming, interference reductions, all those.
So the decisions, we know today that networks are designed differently. For example, in Boston, they've got trees, they've got leaves, they have snow, versus West Texas, none of the above, right? And flatter. You're saying that we take that and we kind of blow it out to the nth degree, that there's micro decisions made on how the network is designed.
Yeah, and so things like morphology, things like topology. Morphology is clutter and trees and buildings and all that. And then topology is how the terrain rolls, right? Denver's a lot different than Phoenix. I always loved building networks in Phoenix. It was real easy. They only give me 60 feet. I knew how far I had to go.
Right.
When we first started in this industry, how do we design cell sites? Why is it called a cell site? Well, we used to put an antenna up there, figure out, okay, this area, it's a honeycomb design on a USGS map. We place it. Then we got automated tools. Now, the tools are going to have their own models, their own learned language models with intelligent decisions, understanding this is where the interference is coming, this is how it models, this is how it drives. And by the way, we're no longer dealing with the foliage issues, leaves falling, leaves coming, which we're experiencing today. That's what's exciting about operating a network. I'm probably 20 years too late. Because that's been great.
You got time yet? You got time. Jonathan, you go into a building, you go into a hospital, etc. How do AI tools play in it today? What do you see happening?
Yeah, I mean, for the in-building space, kind of bookending what Tony was talking about from a design perspective, there's several industry standard RF design planning tools. Those are going to continue to advance over time just to support, quicker, more efficient, better designs, and even bridging that gap with the wireless carriers. I mean, frankly, we have to ensure our networks meet and exceed their national RF requirements for in-building coverage. So that's a big part of it. And how AI can help with that is maybe do it quicker, but AI is not going to be able to change Verizon, AT&T, T-Mobile's mind yet, right? Until it gets to the next level, I guess. So we really want to support the carriers in that regard. And then on the operations side, just kind of at the other end of the bookshelf there, our network operations center, we're a very lean shop. So AI and just various AI software tools are going to allow us to be more human efficient, not replacing people, but force multipliers. And we're really trying to not only apply it to our networks, but apply it to our business. AI to airwaves means airwaves intelligence. And that's how can we be good stewards of AI for the business. And not only us benefit, but our clients benefit from that as well.
Did you patent that term?
Ian already took it.
Oh, okay. I was going to say,
Yeah.
Who's getting the royalty?
Yeah. You didn't get the release that you signed when you agreed to this panel? Huh?
I don't know what I signed.
Okay, Akhil, I'm going to put you on the spot a little bit because we hear about AI RAN and we hear about all the things the RAN could do, will do, should do. So what's it doing today what's being used within the RAN today on AI? Actually, all the core as well. You got the core as well.
No, for sure, right? When we look at AI in the network, we essentially look at it across the portfolio. AI in the RAN, AI for the RAN, and then essentially how you look at it beyond the RAN as well for core and IT systems. So if you look at the RAN itself in terms of feature functions, we have built up features like AI native link adaptation for modulation and coding schemes. Here we are looking at almost 20% improvement in downlink traffic and downlink throughput, and about 10% increase in spectral efficiency. That's here and now today, right? We have done some field deployments. We have seen such improvements. And here, essentially, what we have done is looking at our processor technology, leveraging cloud O-RAN technologies, where you can bring that capability of the processor technology or the processor needs by leveraging a COT server, right? So that's here and now today. Link adaptation is a very good example. In some scenarios, AI is also for RAN, right? It's not distributed, it's centralized. So here, if you look at the O-RAN ecosystem with SMO and RAPs, there's a very good RAP example that we're doing actually with a few of our lead customers, which is all about NSA traffic optimizer. So if you think about FR1 spectrum, FR2 spectrum, how do you load balance and ensure that you're more effectively deploying? There we are seeing 18% improvement in downlink throughput, right? So both link adaptation, traffic optimizer, those are use cases that are deployed or being deployed today. If you go beyond RAN, here, a lot of use cases that we are seeing is about talking to your network, having a good understanding of moving from what's more reactive customer support to proactive customer support. We're also seeing scenarios of automating the network, right? How you translate a business intent to service intent, and then finally a resource intent. A good example that I can give you that's very real time is a scenario where we were doing with a broadcasting company, a live broadcasting company, where we brought in the benefits of private networks, edge computing, and AI together. So this is a scenario where you need to do live broadcasting. You have hundreds of cameras all wired. So the first thing you did is you made all of those cameras wireless, right? Private networks, and that enabled it. The second thing is we worked with a partner who was able to run AI analytics on top of those multiple feeds of video and then immediately select what is important for the context of the game or situations of that nature. So what you're doing at that moment is you are able to create what I call differentiated connectivity and uplink only slices for those specific cameras. So the work as a producer becomes very much easy. So if you brought in edge computing, you brought in private wireless and differentiated connectivity to make sure those cameras get that uplink slice. So the producer's job is very easy. So it's a very good example, close to my heart, and it's a good showcase of how all these technologies can come together.
So all you got to do now is just make sure the 49ers win every time you do that. All right. So I'm going to ask one more question, but then I'm going to ask you guys for any questions you guys got. We've got about 10 minutes for Q&A for audience, right? So start thinking, right? And Mike told me that anybody who asks a really good question, he's going to give them $20. Okay? The check may be in the mail. If I were you, I'd get Venmo. Just let you know. All right. Okay, Akil, I'm going to let you go first because I've got my order out a little bit. As we'll go, Akil, Tony, Jonathan. Stretch it. Far future, right? Where are we going to go with this, right? What's the, so we hear about self-designing networks, right? And self-optimizing networks, except we've had that for a while, but the networks that design themselves, the lights out networks, nobody touches them. Is that real? Where do we go with this? How far ahead? You're a young guy, you've got plenty of time.
So if you look at it in three horizons, right? The near, the mid, and the long, we are actually implementing a lot today. The link adaptation example was a good one. Talking to your network, having agents being supportive from a customer support point of view. Where we see in the short horizon is that shift of paradigm from autonomous network, which is today human assisted. It's based on static rules, maybe in some scenarios, dynamic rules by Python scripting and things of that nature. So we see within a 3-year horizon that there will be an inflection where you move from a human-assisted system to an AI-assisted system, right? In the industry, we call it as autonomous networks. And how do you drive that? So that, I think, is within our grasps. I think we have the ingredients. It's more about making sure that we have the execution capability and essentially the deployment within our carrier community. In the long-term horizon, I'm an optimist here. I think that we are more closer to a cognitive network where it's self-healing, self-optimizing. We have had some early scenarios with our apps and what we have done in the past with SON. But given the capability of what AI can provide and the information that we are sitting on, like this community, this industry is sitting on terabytes of data that we can actually actuate upon in a very meaningful way. So I'm a guy who sees the glass half full, right? And so I think that the cognitive networks is going to be a reality. And as an industry, I think we should make that a vision when 6G comes in. So we have the networks ready, so where we can think about a truly cognitive network where applications or network components are talking to each other and self-optimizing for the needs of the user behavior.
Okay, Tony, where's this going to go?
whether it's a network or whether it's everybody's daily scales, AI incorporates a terminology called 30% factor. What this means is
Well, hold on. Your scales, your daily scale, you mean your scales are reading 30% low?
30% factor. So what it means is that if you've got a workload of 100%, 70% of that work will be delivered and all the information in front of you, right? And then the humans come in. I know you're joking with me, but the 30% of that work is really where you spend your time. I mean,
Yeah,
it's not working. So it is working?
there's a concept here like
It's
that.
got well, minor homework's like this. Anyway, so the 30% factor goes back and says, okay, we're going to use data, informed, correct, accurate data. That's kind of what Grok tries to do versus the others, right? It's very good sources. And you take that data and you have it in front of you. So now although you may spend 80% of your time on Teams calls today, that other 20% can actually be effective for you and you get things done. And so it's basically taking this information and AI delivering the things that you need to have in hand to really accomplish without having to do all that research or gathering it, whether it's being on top of the network, whether it's be designing the network or implementing those things that are in place. I think the one key we want is dynamic spectrum allocation. Because as you start thinking about the balance of downlink and uplink, well, today, usually on a TDD spectrum, which is the C-band, that spectrum really allocates about 80% of that spectrum for downlink and 20% for uplink. You have to fix it statically. Now, dynamic allocation says, well, hey, wait a second. I've got everybody at the football stadium. They're not pulling down stuff. They're sending this interception play to everybody else out. So the ability to do that, AI will have the intelligence to swing that based on traffic needs. So I am half full too. This thing is it's gonna be better than we thought. So I'm pretty excited about it.
Okay, good. Jonathan?
Yeah, building off
Stretch it.
building off of Kill's statement, really for the in-building ecosystem. I absolutely believe we're not that far off from the self-design, self-optimized, self-healing networks. And that's kind of crazy to say out loud because, my day-to-day is to not necessarily always chase the shiny objects, but be aware of those and how they can impact our business and our customers. But I truly believe we'll eventually get to that point. And at Airwaves, we don't manufacture any specific equipment. We partner with Ericsson and other OEMs. So, I think it's incumbent on all of us to really try to push the envelope there and make that a priority. Again, putting the carriers first, right? Because they help control a lot in our industry. Hopefully they're going to get behind that. And we heard earlier, that is the vision, right? To continue to push networks to the edge for whatever the edge definition means to you. For us, it's the mobile device, the end user in all four corners of the building. And we're going to be able to hopefully do a one-click design and turn up here and go about our day soon.
All right. Questions? Anybody? Yes, there's one way in the back. Oh, so Yago mentioned the iPhone moment, right? He didn't say when it was, like Tuesday at 3. What, Jonathan? When is it?
I mean, I'm sure there's many thoughts here. To me, it's what is the killer app, right? And from an indoor perspective, what we see today in the market, obviously the importance of being prepared for AI and data demands, but it really is as simple as making phone calls in a building. So I think once the app community comes together and a lot of smart people behind those, it's really going to be something revolutionary. I don't know what it is yet. So I don't know.
Tony?
I think specific to the iPhone, they got a big moment coming up with the new phone that's coming out because this is the first time Apple actually owns all the core systems to it. They're announcing it as their own on-base AI chip. So they're controlling end-to-end the functions within that device. It's a pretty strategic move and pretty eventful.
Q?
I think we won't get an iPhone moment, but what we will get is a change of the economy itself, right? Today we have an app-based economy. I think in the future, the devices that will drive is a context-based economy. So I think the moment is going to be more about which will be that device that will drive that. Is that wearables? Is that smart glasses that will actually upend our current traffic profile? We can only guess, right? If I were to forecast, I think we are more closer to that than ever before. The investments that's happening with Meta, with smart glasses, I think that has probably the most potential for us to start seeing those leading indicators for changing the traffic dynamic.
I don't normally answer questions, but this one I will. I actually think it's down to trust, because my kids are young, and they do crazy things that I would never do on the internet, right? Like the stuff they upload, and Dad, don't worry about it. And I do worry about it, and my wife's paranoid about it. So when a voice starts telling her, do this, do that, she's like, oh, I'm not gonna do that. But she has things she trusts, like maps, right? If the maps tell her to drive a different way, she will do it because the map told her to. But if the voice said, don't go this way, go that way, no, I'm not listening to that. So it's a trust factor, and I think it's how it's presented and who is presenting it. And that comes down to a lot of media and press and, you know, stories of bad things. But also we kind of need the good stories. So I think it's going to take a while, but I think it's down to, I don't think it's necessarily technology, it's rather the trust factor. Or just people like Tony and I basically get older and go away, and all the young people go, yeah, what are you worried about? It's been fine all along. Yeah. So, all right, anybody else? Patrick.
Yeah.
Oh, cool, a microphone. I've heard you talk about, Tony, cell side of the future in various forms. Can you talk about how you see the infrastructure, if you will, from the macro to any other sort of physical infrastructure, and how that might be affected by everything you guys have been talking about?
Well, I think it's only a matter of time that the cell site goes to a blade formation like a data center. You guys got to get out working on that. But the fact of the matter is that I've got to buy boxes that are, you know, Ericsson E-nodes and all that. It's going to be blade. It's going to look like a blade server sooner or later. It's going to come. And when you do that, it doesn't change the radios, right? You still need these radios, and they're not changing what's going on the tower. But really, the idea of full-blown, almost like rack space base station systems at the cell site, or even a data center that swings to a site where I don't need very much equipment at the site, that it will evolve to that. And we're pretty excited about that. O-RAN's one step, right? It's the first step of many of this. And so it's going to be simplistic, but it's really not changing the top side, because physics are physics.
Physics. All right, good. Okay, last things. We're about out of time. We did well. Well done, guys. So on this one, last one, Jonathan, Tony, Akil, you get the last word. So Jonathan, 30 seconds. What keeps you awake at night? You can't say the dog barking, you know, your teenager out at night or something like this. What is it that keeps you awake at night? We need to worry about in the industry. And you can kind of make it a positive, right? So yes, we're addressing this, but we need to spend more time, or you can make it, no, really, guys, you need to worry about this. So what is it?
Yeah, as I thought about this, I'm gonna go quick here. I tried to think about what would be relevant to everybody in the room. And as we talk about policy and everything, and looking internal to our business, what keeps me up at night is just the cybersecurity piece of all this. Everyone needs to care about that, right? And making sure we have solid AI policy, evolving AI policy that keep up, and not just put a policy on the shelf and 3 years later figure out what it is. With agentic AI, the advancements and how fast they're moving there, you know, they can quickly be a bad actor, and it's a one-click button, and you never know things are happening. So cyber for me is, there's always one eye open.
36 seconds, very good. Yeah. But you could have done better.
Could have done better.
Tony?
I could beat it just by saying what he said, but no, I'm going to go.
You're already 3 seconds in, so keep going.
It's all right. You already owe me 30. So anyway, my view is what kind of really concerns me is what you mentioned earlier, the truth in data and the truth in what we're utilizing to make these decisions. AI, the big threat, and you've seen some industry people talk about this, is AI just still needs to be controlled in some way. It could be very detrimental to a network if the wrong information is being allocated or laid out, or the wrong decisions or the wrong methods. And so to me, is AI being utilized in networks running astray. The ability that somehow erroneous, and it can happen, gets in there. So the control of it. Good?
So I'll not repeat because those are
42 seconds you got, but we'll take 3 off because I was talking as well. So 39.
So I'll try to beat them then.
Yeah.
So, you know, I agree with both the points made here. Maybe the other thing that, you know, we as an industry, and for me that keeps me up at night, is how do we ensure that the good work that we're doing on the spectrum side of the house can be realized in a timely fashion? I think one fact is, okay, we need, you know, Yago said 400 megahertz of contiguous spectrum to bring all these innovations to the wireless applications. But at the same time, as a community, we need to come together so we can have those spectrums available in the right time frame. 6G is only 5 years away, and the planning happens actually much earlier. So we need to start thinking about investments, decision making in the next 18 months or so. So we have that pipeline in place so for us to realize the innovation.
Let me just put one thing on top of that.
Yeah.
What's important about the Gs is also spectrum policies linked in there. So 5G had different levels of adding CBRS. Then, 4G, you added the 2.5 spectrums, you added satellite with some of the parts of 5G. It's very important that we know what spectrum bands are coming now as the working groups are starting in 6G to start putting those spectrum pieces in the policy.
But what I'm hearing Akhil saying as well is, give me the spectrum, but if I'm a carrier, make me use it within a time frame as well. So yes, you can give the spectrum, but you've got 5 years to deploy it or 4 years to deploy it.
I like that concept. Not going to happen.
Second.
All right, with that, we'll leave it right on that point because it's a good point. Thank you. This is great. Good panel. Thank you.
Thank you.
Okay. We are rolling right along here. So it is actually in a welcoming of welcomes. It's my pleasure to welcome me because I'm going to be moderating the next session here. And the next session is on policy. We've heard a lot. We heard Iago talking about some of the, the use cases, the network, what we need to build out the network of the future. But a lot of what we need is also going to happen here in DC. And so the discussion now, and we have a very esteemed group of leaders to lead us in this discussion, is about policy. Let's talk, how do we get there? How do we set the framework to make sure that we have everything that we need? So please welcome to the stage my next panel. Yeah, wherever you want, wherever you feel comfortable. Can you hear me all right? Okay. All right. I said we have and I would encourage all of you to check out their robust and august bios online. But let me just go through and introduce who we have here. And if you could just say 30 seconds or so about what your role is. So let's start with Josh Koenig down at the end here, who is Executive Vice President and Chief Administrative Officer and General Counsel for SBA Communications.
All right, I'm down to 5 seconds. So yes, Josh Koenig, Chief Admin Officer and General Counsel at SBA, oversee our legal group as well as our corporate affairs, M&A, and a handful of other things at the company. But we are a independent owner of towers and other wireless infrastructure.
Great, thanks, Josh. Arpan is the Senior Counsel for FCC Chair Brendan Carr, and he's also the Chief AI Officer. So Arpan, do you want to explain your role?
Yeah, I basically wear 2 hats. I advise the chairman on spectrum, space, and technology issues covering the Wireless Bureau, Space Bureau, Office of Engineering and Technology, and the National Affairs Office. I separately have a role as Chief AI Officer, which I'm eager to talk about during this conversation.
Great. Thanks for being here, Arpan. Next up, we have John Kusin, who is the SVP of Spectrum Policy and Regulatory Counsel for Qualcomm. John, you want to talk about what you do?
Sure. So I'm based in Washington, D.C. I at the FCC, and I also oversee Qualcomm's global spectrum policy team.
Great. And last but not least, Matt Pearl, to my right here, who is the Director of Strategic Policies Program over at CSIS.
So I basically cover any technology that has geostrategic significance vis-a-vis the People's Republic of China, other competitors and adversaries, and really work with policymakers, business leaders, and so on to make sure that the U.S. maintains its edge and we're adopting the right policies. Should also say I'm of counsel at Jenner and Block as well.
Great. Thank you for being here. So today, it's almost like Iago's speech laid this out perfectly, because we're going to talk about AI and the infrastructure and the intersection between the two. We're going to talk about spectrum. We're going to talk about 6G. We're going to talk about policy and the government's role. And to your point, the global race for AI leadership. So lots to dive into today. So WIA's position, and I was so glad that Iago mentioned this as well, but our fundamental core point is that wireless infrastructure is AI infrastructure. So if you leave here today with nothing else, that is the core point. And this is a jump ball. We heard a lot of basketball metaphors on the last panel. How do you think about the role of wireless infrastructure, big picture for overall AI and its success?
I'll go first. As Iago laid out, the wireless infrastructure is absolutely critical to the success of AI. As you all know, no one plugs anything in anymore when you want to connect to the web. And that's just the way we live. And in addition to having a need to increase network infrastructure, and we're going to get into it according to what Mike laid out, spectrum is critically important. And then from Qualcomm's perspective, we're working on this, enabling this world where the devices in your pocket also have a high level of intelligence as well and work in concert with the network-based AI. And I'll get into that a little bit more, but it's absolutely critical to have advanced network infrastructure to support the continued growth of AI.
Iago, sorry, go ahead.
So just to build on that, I think the AI race in many ways, the focus has been on data centers. It's really actually going to come down to two things that are related. One is wireless connections at the edge, and the other is edge devices. And that's a synergistic thing, right? The more connections you have, the more latency you have, the more you have sensors, drones, all of these devices. And so ultimately, infrastructure is going to be where that happens, serving all those locations. And that's where you're going to both see inference take place, AI inference, which is going to be critical and is going to potentially give the US an edge over the PRC, as well as actually just to have the latency for those use cases, because in many cases, unless it's close enough to the device, and John can get into this, it just won't, those use cases won't emerge from AI enabled devices.
Yeah, Iago referred to the smartphone revolution, and really what made these devices so critical to our lives is the mobile computing aspect of them, right? In addition to the talk and text. And AI is another use case for mobile computing, right? And it needs a delivery mechanism, and that's what wireless infrastructure is. And just like in prior economic booms that were more industrial in nature, you had roads and waterways paving the way for those. You need an enabler for the AI boom, and that is wireless connectivity.
So Josh, stay with you for 1 second. Under that theory and under the boom, how are you seeing the need for additional capacity playing out within the networks that you're building?
Well, we are certainly seeing an increased level of activity across the ecosystem, but I think there's going to be a lot more to come when the new types of devices that people have been referring to come online. Especially while spectrum is limited now, there's going to be a need for more coverage sites, and more sites means more towers, it means more fiber connections, more in-building solutions. So the level of activity is going to continue and amplify as more devices come online. You know, the Ericsson study that we all refer to is again predicting wireless usage to more than double again by 2030. So that will prove to require a lot more infrastructure.
Right. Well, and along those lines, I mean, we're talking about infrastructure, we're talking about policy. Let's figure out how we're going to make that happen. So Arpan, would love to welcome you into this. Chairman Carr's guiding principle so far has been the Build America agenda, which I think I will speak for WIA. We've really enjoyed seeing that come to light so far. How does the FCC see infrastructure contributing to our mission, and what is it doing to promote infrastructure generally through the Build America program?
Infrastructure is critical, and we're taking a variety of measures. But just to step back, in June, Chairman Carr had his Build America speech in Sioux Falls. And for the first time, he announced a unifying agenda that would span all of the functions of the agency. Build America has 6 pillars, but 3 of them are relevant today. So half of the agenda is very central to this conversation. One of the pillars is unleashing infrastructure builds. Another pillar is restoring America's leadership in wireless. And a third is reducing red tape. And when you put those 3 things together, you enable the kind of infrastructure that will allow America to lead in the AI age. And this is sorely needed because over the last couple of years, we have seen a lag in the development of infrastructure. Infrastructure on the ground is necessary to support digital technology. You need data centers, you need towers, you need energy. But with the BEAD program, with the CHIPS Act, you can see example after example where we were not able to build things in Earth due to regulatory sclerosis. And one of the elements of that regulatory sclerosis is the abuse of laws like NEPA. NEPA is a procedural statute that is supposed to apply to a very narrow category of activities. But in recent years, it has become a hotbed for abuse and litigation and slowing down clean energy projects, slowing down wireless infrastructure, slowing down other major projects that are necessary for America to compete at the global stage. And as an agency that has NEPA rules, it's incumbent upon us to take a fresh look at our rules to make sure that we're complying with the law, that we're acting within our very narrow lane, and that we're doing so to promote the public interest by spurring innovation and allowing the kind of infrastructure to be built that enhances network capacity. That's what we've started to do here at the FCC. Earlier this summer, we released a notice of proposed rulemaking that would seek to fundamentally overhaul the way we do NEPA regulation and come more in line with the narrow remit that Congress assigned to us. We also are taking a fresh look at our rules to preempt state and local regulations of wireless facilities. Congress gave us very sweeping and powerful tools to preempt state and local rules that prohibit or have the effect of prohibiting wireless infrastructure. We just voted that out a couple of months ago. And we have some other infrastructure items in queue. And so we're very excited to take this on and see a lot of opportunities here.
Yeah, thank you. I mean, certainly the influx of infrastructure policy has been notable and palpable from the industry side and our views. And I will tell you that I've been doing this a long time, but I have never heard the term regulatory sclerosis before. I wrote that down on my paper here. So I appreciate that viewpoint. All right, so one more is kind of scene setting question. AI, hot topic, AI, we know. So it's hot topic. What, though, should we be talking about more? Is there something that we're missing in the AI policy topic that is really kind of under the radar, or what is just getting too much discussion from a general level? Another jump ball.
I'll jump in. I mean, obviously, as we referred to before, we're not talking enough about the delivery mechanisms that AI will need. So certainly infrastructure is one area we should talk more about. As Arpan mentioned, We've got a great opportunity to codify a lot of the FCC rules and regulations that have come down in recent years to make that infrastructure deployment more efficient. There's not only going to be the need for new infrastructure, but to optimize existing infrastructure, to modify existing infrastructure. The type of 6G advances that Yago mentioned aren't going to be able to happen through poles and canisters and the type of stealth installations. So I think that we need to look at codifying the rules, referencing rules like 6401 or 6409 rather. And in addition to that, and actually one element of the Build America that I don't think you mentioned is workforce development. We need an AI-ready workforce. The workforce in telecom is very specialized as it is, and we've seen challenges in that. So we need to continue to train that workforce. We need to continue to make them ready to embrace AI. And we also need to start talking about how we utilize AI to make their lives better, to make them more efficient, and to make them safer. Our industry has real men and women that are out there in the field. They're climbing towers, they're building telecom infrastructure, and AI has got the capability to really enhance their jobs and make them safer.
So I would really highlight integrated sensing and communications. I think that's going to be a game changer, and outside of our community, people aren't talking about it. But that's everything from improving spectrum use to detecting first responders under rubble to everyone saw what Ukraine did to Russia with a cargo container of drones, right? Like if every commercial mobile network had the capability to detect those drones, that would be really critical for protecting our country. And so that's just a technology that folks aren't talking about that's absolutely critical, and we'll need access to spectrum and all these policies that we're talking about.
One of the things that I think is maybe underappreciated by those that don't really work on spectrum as much as a number of us up here do is that while the One Big Beautiful Bill set out a wonderful framework for opening up spectrum for the next several years, and it identifies certain bands that need to be studied, it identifies wide bands that need to be studied, which is critically important. That is actually step one, and a lot of work needs to happen here in America for us to keep pace with the rest of the world. The rest of the world today knows where they will be deploying 6G systems. In the US today, we have bands that we're looking at, but we still don't know what frequencies are going to actually be supporting 6G networks. A lot of work needs to occur. That work needs to start already. Another critical piece of that that's underappreciated is the importance of having industry work very closely with the federal agencies that are currently operating in the band, because that's how we're going to get to good solutions that open up spectrum that we need to deploy 6G in the 2029-2030 timeframe. Again, kudos to all of you here that helped pass the spectrum provisions in the One Big Beautiful Bill. But now the hard work begins, and it is not going to be easy. But we know what the challenge is. We know how to achieve the goal. We now have to do it. And we're going to do it by working together early and often. And I think that what's underappreciated is just the amount of work that needs to occur. And it is not going to be easy to enable America to keep up with the rest of the world that will be deploying 6G in 2029, 2030.
If I could just add one thing quickly on that he's talking about sort of the front guard action. There's also the rear guard action we're dealing with right now in the NTIA. And some folks in Congress, a constituency that's trying to take us backward by inserting language in there. So we need to be mindful of that as well on spectrum.
Could you unpack a little bit more about what's going on with the NDA? Because I think it's an important element here.
No, go for it.
I mean, obviously it's in flux. There's various language, but it's essentially taking bands off the table, bands that we're going to have to look at. And it has really important consequences for what John is talking about in terms of work in U.S. leadership where there are bands like 4 gigahertz, lower 7 gigahertz that could potentially be internationally harmonized. And so if you start taking bands like that off the table, it's really going to hamstring the U.S. and our ability to lead.
Yeah, let me just amplify on that a little bit. We lost our auction authority several years ago and went without it for several years thereafter. And we just got it back this summer. And that was supposed to reflect a political settlement. And so it would be quite odd and quite counterproductive to try to revisit that settlement. What's done is done. We have a spectrum roadmap for the next decade. Let's now execute on that instead of trying to go back and take another bite at the apple or secure better terms.
Right, and we heard Administrator Roth speak last week about introducing the 4 gigahertz band into the conversation as well, in addition to the 2.7 and the 7. So there's a lot of interplay, even with what you just said, some of the potential legislation and how all of that would work. It's a really complicated puzzle out there, but I will say that you all have seamlessly segged into the AI spectrum and 6G discussion. So well done. But let's talk about 6G. Let's talk about AI. From my understanding, the two are really going to go hand in hand. Can someone explain how that's going to work, how the two are going to be codependent on each other, and what we need to do about it from a policy basis?
I'll take a crack, and I'll try to be brief. So the 4 main drivers of mobile data growth are mobile gaming, increased video consumption on your devices of higher quality video, XR, eyewear, connected directly to the cloud, and AI. We're seeing, with regard to XR, the Ray-Ban glasses, Samsung announced new eyewear yesterday. These devices, as Yago laid out and others have mentioned on the previous panel, they're going to generate a very high amount of uplink traffic. Think about wearing glasses, watching your kids play soccer, and being able to stream the game to grandparents who can't make it to the game or could be on the other side of the world. My favorite XR application is going to a sporting event and being able to watch that sporting event. Just it's a World Series time now. Being able to watch a baseball game from the perspective of the umpire or the second baseman. And you're thinking, why do I even need to go to the stadium in that case? You don't. But with high quality, high capacity networks, you could have these capabilities. They're going to essentially require a re-engineered network where you're going to have a lot more uplink demand. Now let's talk about AI. Why is AI, why do you need a lot of heavy networking for AI connectivity? What we're going to be doing with these agents that have been mentioned is you're going to instruct an AI agent and give it a task. And it's going to go off and do this task for all of us. For each of us are going to have our own various tasks. That is going to generate a hell of a lot of traffic. And you might be sitting there going, what the hell am I talking about? Well, here's one example. You say, I want to go on a vacation within the next 6 months. I want to leave on a Thursday or Friday, come back on a Monday or Tuesday, want to go to Maui, want to stay at a Hilton or Marriott property, want to fly on these airlines, and I don't want to spend more than X. That agent goes off, and what is it doing? It's doing what you would do on a Saturday morning in your own house, waste 2 to 3 hours planning your vacation. Well, if we all have that capability, we're all going to take advantage of it. That's just a little example. That little example shows you why AI is going to drive massive increases in mobile data. Estimates show that in 2033, a third of all mobile traffic will be AI related. I'll leave it there.
Other thoughts?
No, it's the new use cases. You've heard about the glasses. We know about the new smart ear pods that are capable of translation, and if they're capable of translation, they're capable of transcription. And I can barely listen to one conversation at a time. They're always going to be on, and they're always going to be computing, and we're always going to want access to those agents. So it just underscores the upcoming demand on the networks and the delivery mechanisms that those machines will need.
When we're talking about the intersection of 6G and AI, it's just important to begin with a caveat that standards are still under development and, to some extent we're projecting. But there are a couple of elements of, that intersection between 6G and AI that we feel reasonably confident we know right now. The first is that AI is going to be baked into the 6G network intelligence. The second is that AI is going to create a huge spike in traffic. And then the third is that we know that these 6G networks are going to be designed to be both intermodal and multimodal in nature. So when you think about it from the perspective of policy, what can you do to foster our 6G future? First, don't make network intelligence illegal. And we, fortunately, a court struck down the previous administration's Title II rules, which would have threatened network slicing, among other things. So don't get in the way. Number two, focus on the bread and butter issues of spectrum and infrastructure. We talked about that, but there are only just a few ways that you can increase capacity: spectrum, infrastructure, and squeezing more out of your technical rules. So you can't lose focus on the fundamentals. And then third, focus on intermodal and multimodal competition. You're seeing that in the market. We need to change the way we look at competition and recognize that maybe the layer cake won't be 3 terrestrial bands. Maybe it'll be a mixture of satellite and terrestrial. Understand that business combinations are happening between providers that used to live in drastically different regulatory silos. And turn off like this sort of old blinkered mentality where different services don't exist in the same competitive landscape. Those are things that we can do now and that we are trying to do right now, which I think will clear the way for 6G adoption.
Yeah, that's good. So, John, question for you. You talked about spectrum and the need to get it right. Is that at the top of your policy wish list?
Yes.
Is there anything else on your policy wish list?
Well, after it all kind of flows from spectrum, and folks will say, what will happen? Let's just say the U.S. Doesn't open up spectrum for 6G in a meaningful way. And what we're talking about are blocks of spectrum between 200 to 400 megahertz wide per carrier by 2030 for there to be meaningful deployments. So what's going to happen if that doesn't happen? Well, it's not like the networks are going to stop working. But what's going to happen is you will experience delay. And I read a study showing that 10 years ago, many of us would wait a few seconds for something to load. Now you wait less than a second, okay? But just by nature of things being delayed, it's going to impact the technical feasibility, the success of many new applications. The latency will suffer, the response time. So I can't tell you now what's going to break or what's not, but for those countries that have high capacity, low latency, highly reliable networks based on wide channels, they're going to have a lot more benefits and the ability to build new applications and services that at some point in the US will be very problematic because the networks will be increasingly strained.
Thank you. Matt, let me bring you into this for a bit of a different perspective. And you wrote a fascinating article recently, 2 weeks ago, thereabouts. It's very relevant if you just listen to this title. 6G and AI, how wireless technology and edge devices are shaping the global race. So what prompted you to write this, and what are your big takeaways? And tell us more about the national security angles that come with 6G and leadership there.
Yeah, so I think two things. I mean, one is to write about 6G, which, as Arpin notes, mentioned it's still developing, right? But to get excited, to get people in DC, policymakers on the Hill, in the administration, excited about the technology, right? Like that's where it starts, is understanding that something is coming. it's significant, that's going to create an impetus. And then secondly, to essentially for a lot of what we're talking, spectrum, workforce, and so on, to really make the case that it's a national security issue for several different reasons, right? It's a national security issue from the standpoint of technological development, economic growth, AI deployment, all the things we're talking about. It's also a national security issue from the standpoint of like literally what our military is going to use. Yesterday, I was at the U.S.-Taiwan Defense Conference, very different crowd than this, right? Like a lot of military people, a lot of defense industrial base people. And I was on an electronic warfare panel. And the person who shall remain nameless from the defense industrial base was proudly saying how they were designing an EW system that used a lot of off-the-shelf hardware. And the reason that he was saying that was because their extremely exquisite systems in Ukraine are getting killed by the Russians, right? And so we need this commercial technology using AI, sensors, wireless devices to develop. And then our military, our companies that are building things for the military can literally like leverage that to defeat the PRC. And so there are just so many different angles to it. And unfortunately in DC, people tend to like chase like one or two problems. And so as I mentioned, and Arpin has mentioned, people have been really focused on data centers. They've been really focused on energy. Those are both important, but we have all of these other bottlenecks, spectrum, workforce, other things. And quite frankly, the PRC and some of our other competitors don't have that problem.
Yeah, we use the word convergence a lot in our industry, and I think the theme that's emerging here is we need a convergence of regulatory agendas as well, because you simply can't talk about AI without talking about 6G, without talking about workforce development, without talking about infrastructure. And there's going to be a lot of resources that are expended in the coming decade on all of these things. And those resources need to be spent efficiently, right? So that we end up looking back and seeing the true potential of these technologies being unleashed and being unleashed in a way that is economically efficient.
Any other comments? All right, let's, Arpin, I want to come back to you. And I realized I was remiss. I mean, we are in the middle of a government shutdown, so we truly appreciate you taking the time to be here with us today. So thank you for this. I know it's difficult times all around and hoping to see the FCC back at full strength soon. So much appreciated there. But hoping you can spend a minute now talking about the FCC. What is the FCC's role when it comes to AI? Can you describe, and you've got a very interesting title, Chief AI Officer. What does that mean? How do you see the agency and what's your role in all of that?
So on the issue of AI, the FCC has an inward-facing role and an outward-facing role. Let me talk about each of those. I'll start with the inward-facing role. How do we use AI within the agency? And that's where my title comes in as Chief AI Officer. For the first time, every federal agency had to designate a Chief AI Officer, and their formal responsibility is to drive innovation, adoption, and governance of AI within federal agencies, and that's what I do. Essentially, in my role, I set the strategic vision for how we think the agency should be using AI, and then leverage expertise across the agency to make it happen. Here are a couple of things that I think we're going to try to do here at the agency to start. First, we're going to focus on manageable, easy problems that have high leverage. Second, we're going to focus on augmenting our workforce, not necessarily replacing them. This is a net add. We view that as such. Third, we're going to focus on products and not just technology deployment. We're going to focus on solutions that make the lives of our staff easier, that make this place a better place to work, and focusing on improving outcomes. Because ultimately, at the end of the day, what we're trying to do here at the federal government is serve the public more effectively, to be faster on applications, to be faster in decision making, to be more accurate in the kinds of decisions that we make. And we'll be looking at the technology suite with all of those things in mind. I'm pleased to say that the government has stood up an AI council where there's information and code sharing, where there's off the shelf, security compliant solutions that can be rolled out, expertise that we can draw on, and that's making this journey easier. We're not going it alone. There's some sort of support system there to make sure that agencies are doing this the right way.
That's great. And if there's anything we can do to incorporate AI into ULS or some way, bring that into the 21st century, we're all about that too. Well, but staying with you, Arpin, for a second, we've got President Trump AI Action Plan, which is probably the ultimate federal guidance that we have out there now. And one of the, I think, fascinating pieces of it was that it calls for the FCC to evaluate the impact of state regulatory actions on America's AI future. So can you elaborate on that charge, how the FCC is thinking about that and how you're thinking about responding?
So I mentioned a preemption item. There are actually two preemption items from earlier, just a couple of months ago. There's a wireless preemption item and a wireline preemption item. And in both of those, we seek comment on our preemption authorities under sections 253 and 332 of the Communications Act. Congress gave us sweeping authority to preempt state and local regulations that prohibit or effectively prohibit telecommunication services and personal wireless services. And consistent with the charge in the AI Action Plan, those two items seek comment on the extent to which our statutory authorities would extend to AI. And so, it's a very interesting question. We look forward to the record developing on that.
Well, and so I will toss this out to the group. And I think as us in the wireless infrastructure space, we are well aware that there's a federal rubric, but there's also state law, and there's a local aspect to this too, because infrastructure is inherently local when you're placing something in someone's backyard. So there's a lot of different regulatory constructs that are flying around out there. But how do we, so I think we all want our AI future to succeed as a nation, but there are different views, even at the federal level, as to how to get there. Then there's all these different state views, which you may or may not have a role in preempting to the extent that they have a negative effect. And there could be local rules too. So how do we deal with the potential for a fragmented regulatory, political, legal policy arena when it comes to AI moving forward? Any thoughts?
It's a difficult challenge, Mike. I mean, as you said, it is in our industry, it is a fundamental tenet that you're going to have state and local regulations to comply with. Zoning is, a part of our fabric as a society, and we're used to dealing with that. But the FCC over the years has done a great job in partnering with the industry to identify bad regulation, because bad regulation does exist. So, it's, as it always is, it's going to be about finding the balance and, supporting good regulation that enables communities to help determine how they look and how they're run, but at the same time not standing in the way of the wireless deployment and the technology that's going to take us into the future. And so that should be, again, to my earlier point, it's about the efficient allocation of resources, the efficient and sensical deployment of infrastructure. But I think the FCC stands in a very good position right now with an opportunity to codify a lot of the rulemaking it's done in the past, working together with Congress. And we look forward to partnering with the FCC and our legislators to strike that proper balance.
Yeah, I think the key word here is Congress, right? This isn't, I'm not trying to dodge it, but they set the rules for what's federal and what's state and local, and they've put their thumb on the scale when they did the 96 Act and federalized a lot of telecommunications policy, recognizing the inherently interstate nature of our networks, It's also reinforced in the preemption provisions that I mentioned earlier. And so, here at the agency, we intend to follow Congress's instructions and, comply with the guardrails that it's set.
Yeah, and I would say from our perspective, from the WIA perspective, we're also looking to Congress really to, one, let's codify what the great work that the FCC's done really on a bipartisan basis since 2009 to set the shot clocks for new towers, just as importantly for co-locating on existing infrastructure. It's the fastest, most efficient way to get things out there. So we're working with Congress on that front now. I know our CEO, Patrick Halley, had a hearing on that, but I hear you that Congress needs to step in, and to the extent that there are more of a framework that we need to be thinking about. It does seem like the role there. Let's stay with Congress and general government officials. So all of you talk with government officials on a regular basis. What are some common misconceptions that you're hearing about AI? Anything?
I'll jump in and go first. That AI is only about the software, right? And at first blush, I think a lot of folks miss the entire ecosystem that's represented, in this room, and that's been talked about in this panel. I also think there is a misconception that that the networks are ready for it all. And as we've discussed, there's going to be tremendous burden on the networks, and there's going to need to be continued investment. So we need the regulators to understand that and to work with us to make that happen in an effective way. And again, as I mentioned before, there's also a lack of focus on the people element of AI. There's a lot of discussion about AI replacing people, but not enough discussion about preparing the workforce to leverage AI. And I think that's really important, particularly in the industries represented in this room.
So I should start by saying that there are so many really dedicated public servants who do know this stuff and don't ask stupid questions or have misconceptions. And so, Administrator Roth, Robin Caldwell, Ryan Bash, just incredibly thoughtful questions. I will say that, you do get questions from others who maybe aren't as educated, just a misconception that sort of LEO networks are going to solve this and can reach everywhere and do everything. And I'm a huge advocate for LEO networks. They have incredible geostrategic significance. I have, the utmost respect for what those companies have accomplished. And so it's not to downplay that, but in terms of the density of use that we need for all the things we're talking about, that's not going to be sufficient. And so sometimes there's a misconception there.
One thing that I would say that.
You can just turn it off. It was on before.
Hello? Thank you. I wouldn't say that there's a misconception, but I would say there's an underappreciation of the importance of edge AI and on-device AI. Yago rightly said in his keynote that network-based AI is 18 to 24 months ahead of what you can do at the edge or on devices. That said, edge devices are going to play a very important role in the success of AI. If everything you do with regard to AI has to ping the network will be overwhelmed. So today, we're all using edge AI, on-device AI. Your devices today can do real-time translation. You could have a conversation with someone in another language and hear their language being translated and engage in a conversation. You can shut off your Wi-Fi or 5G connection and your device will continue to perform. A lot of the things you do also on your device, like let me see how my living room would look with this color, or how does this dress or this suit look on me? All of that can be done on the device without any connection to the network. And by doing AI inference, running searches on the devices, you are saving energy, you're saving network assets, you're saving water, and the latency is close to zero because you do not have to wait for the network to respond. There's a lot of benefits. Two other very important benefits is by having your data on the device, it's safer and more private. So those are like some other benefits. Nonetheless, Qualcomm's also in the data center business, right? So we're interested in seeing both, but you're going to need both. This hybrid AI functionality where you have edge devices with AI as well as network-based AI working in concert is how this is going to scale. What's the right percentage? What's the right amount? I don't know, but we do need to recognize that edge devices are going to play a critically important role.
All right. So let's switch a little bit to the, just in the interest of time, the global race for AI leadership. So Matt, I've heard you mention China a couple of times today. When we talk about the AI race, I think when we had the race to 5G, it was the US versus China. Is it still a two-country race? Are there other countries we need to be thinking about in this?
I would say that it's primarily China. We have partners that are making spectrum available and have great ambitions like India, but that's very different, right? Where it's not an adversarial relationship. So it still is the PRC, and they have a lot of advantages. Unfortunately, right? They can just essentially like mandate that companies use a bunch of IoT devices and sensors, right? And that's at least for a time going to really spur their deployment, right? So. As well as having that command and control ability on spectrum. So ultimately our system is better, right? Like I believe in it and we're going to prevail, but yeah, they bring a lot to the table and are the main concern.
So just to put a fine point on it, what exactly is the importance of us winning? And the second point is, and I would start with Matt, but if anybody else has opinions, I'd love to hear them. How will we know when we've won?
So the importance of winning is two things. One is just overall U.S. economic technological leadership, right, which we've had for the last 70 years, right? And so, that just having that role on the world stage. But then, as I mentioned, just militarily, we have a situation in the South Pacific with Taiwan that could turn hot, and having that technology to deter the PRC, or God forbid, in the event of a conflict, having those wireless capabilities that developed here in the commercial sector is absolutely critical. How we won, there are a million different metrics, but I would say that the first thing that I would look to, if you look at 4G, how we won is we made 700 megahertz available before any other country. And then we had this incredible app ecosystem and economy that grew up, right? And so it was just obvious that we had won because you had billion-dollar companies that were built off of that, right? And so it's having that whole ecosystem of use cases and applications, and then American and allied countries around it that are successful.
Any other thoughts?
I think the importance of winning per se is, or I would say leading, is that we're defining our own destiny. And what we have seen so often at the intersection of technology and public policy, which is what this panel is about, is, in this global economy we're living in, those regions, those countries that lead, that move first, define standards that the rest of us either have to work to change and work backwards from, or live within. So I think we are well positioned to lead at the forefront, not only of technology, but in how we use that technology to actually add value, and how we do it in a way that is orderly and overall good for our economy and our society.
Well, I'm hoping one day I'll just wake up to a text message from you, Matt, that just says we won, and I'll know what that is. All right. So to wrap things up, and I do think we can win. Certainly leadership, to your point, Josh, if we get right a lot of the policies that we've talked about today. Ian asked this, and I want to ask the same thing to everyone here. What's the AI policy question that keeps you up at night?
there's a lag between the state of technology and then the state of social practices, like how do you educate your kids? What do you do about workforce? And then also the state of sort of legal regulation. And there's a mismatch between social practice, legal practice, and technological practice. And I worry that that lag may lead to side effects. You know, it's as regulators, we need to keep pace, but not overcorrect or overpredict. And, you know, as a society, we need to be adjusting and, you know, building technology to match our values. And, you know, sometimes there's a period of settling out that happens. And, you know, we need to make sure that we're sort of mindful of that.
That's a really good one.
Yeah, I think to build on that, for me, it's the Brussels sandwich, right? It's the difficulty that companies have complying with the combination of EU regulations as well as California and other states. And it's just a real challenge, understandably. Congress has a role, right? The administration has a role vis-a-vis the EU. And obviously there are different legislators that have different values, but one of the things that I think is so important when you look at the EU or state legislation is like, what is the actual goal? Because oftentimes there are, you know, all these categories and all these restrictions and, you know, but it's sort of like there's not necessarily always a match between all of those regulations and like actually achieving some sort of goal that the public is going to value.
I think it's all of that's right. It's really, are we moving at the right pace, and are we investing in the right things? And I think these gentlemen have said it very well.
The reason why I turned to Josh to answer is because I was going to flip the question, and I was going to basically say, how cool is it that we all get to work on this stuff, right? And to quote Lin-Manuel Miranda, how wonderful it is to be alive right now. I mean, there's a lot of cool shit going on, and it's wonderful that we're working to enable that. So I have no trouble going to bed at night. I do have a little bit of trouble when I get up at 4 a.m. going back to bed because my mind starts working. But it's a wonderful time to be working on these issues. It's a very exciting time, and I wouldn't want to be alive at any other moment than right now.
And I think it's just such an exciting time for anyone who's just a geek about the whole telecom ecosystem, right? We're talking about LEO networks, we're talking about terrestrial wireless network, like just all of these things coming together and being integrated in terms of standards and really seamlessly providing services to everyone and being greater than the sum of their parts is just incredibly exciting.
All right. We have time for one question, but that was such a good place to end. I'm a little torn. So I think we can just be done here. And let's thank everyone for their contributions today. Thank you all. Thank you. All right. All right. Let's see. In the spirit of continuing to welcome, let me now introduce to the stage my friend Katie Saunders. Katie is the Vice President and Deputy General Counsel for Verizon, and she's going to introduce our next guests.
Thank you. So I gather at this point in the afternoon, I'm not just welcoming, but thanking you. Thank you for spending your afternoon here with us in Verizon's Technology and Policy Center. At Verizon, we're really aware of how critical AI will be for wireless in the future, and we're really grateful that you're here. In that vein, I'm going to introduce our last keynote. Today we have Adam Cassidy, Deputy Assistant Secretary and Deputy Administrator at NTIA, and Patrick Halley, and we're going to do a fireside chat. Deputy Assistant Secretary Cassidy, you have a really long title, by the way.
You're not even saying Deputy of Commerce.
Yeah.
For telecommunications and information.
There you go. There's going to be a quiz on that afterwards, y'all. But he joined NTIA in the spring of this year, where he served as the interim administrator. his current role, he works with Administrator Roth on telecommunications issues for the executive branch, on the implementation and the policy thereof. Before that, he was a chief of staff and a senior legal advisor for former Commissioner Symington at the FCC, so he's got a long history in our space, and we look forward to the conversation. Patrick?
One of these should work, my friend. All right. All right. We're good. All right. So the last panel, one of the questions was something along the lines of what are the misconceptions, or when you're talking to policymakers, what bad questions do you get or something like that? I don't remember.
All of them.
No. And Matt said most of the ones that we work with are really smart and thoughtful. And I will tell you that Adam 1000% falls into that category. It's I'm just being honest, it's a breath of fresh air when we have conversations, because you're very inquisitive, you're thoughtful, you've done the research, you know what you're talking about. And so I've set you up for nothing but failure from this point. Yeah. Let's try another one. Try this one. We got 3 of them.
Can you all hear me? Okay, we're good. Okay.
So we've talked a lot today about AI on the network. We've talked about AI in the network. We've talked about the importance of smart policies to get it right. And so just want to talk to you as somebody who I know is a policy expert, but also somebody that spends a lot of time on the technology side and working with different companies across our ecosystem. So from where you sit at NTIA, what is NTIA's expectation for AI and wireless? How much, from your perspective, will it change wireless as we know it?
Well, first of all, thank you for inviting me today. I really appreciate it. No chance I live up to the introduction that you've given me. How will AI change things in wireless? I mean, I would start by saying that the folks who know the answer to that question are much more likely among you than sort of sitting in DC, meaning we should be taking our lead from industry. We should, as a general matter, be crafting policy that is responsive to technology. That is not to say that we shouldn't have policy preferences that align with the strategic value that we see in AI in wireless, and serving the American people and advancing American tech dominance and all of those things. But how that's going to work is going to be largely down to y'all. Now, I have some thoughts around it. I think generally speaking, I am very excited about AI in the network management space, and frankly in the air interface space. So I think AI in the RAN for 6G. You could imagine a scenario in which right now, as you know, your network engineers, they will go out and they will carefully tune and manage and orchestrate the spectral environment between and among carriers in sort of local areas. They will sort of play nicely in the sandbox for the most part, but you could imagine a scenario under which an AI-powered RAN, for instance, has sort of on its own developed the air interface in some area, whereby the orchestration of frames and of spectral usage and so on, maybe even like beamforming, this kind of thing, managing the spectral environment is done in a relatively automated fashion, obviously with network engineering help and oversight and so on. But that alone is kind of significant. I think also, there's this push to, obviously we're in the age of generative AI and everyone's very excited about it. And, our administration is starting to play a lot with Sora right now. We're making some fun memes, actually.
Careful.
What I can say is there's a push to try to draw as much inference as possible to the device. Very often we have a conversation around AI and how telecommunications needs to enable AI. Of course, that's true. And that's true in the spectral environment, and that's true in the wired environment. It's true, in order to have AI, you need to have connections. That makes all sense in the world. And yet right now, I think for the most part, and you guys can correct me if I'm wrong, but right now from the mobile device, the sort of killer app is like, let's say it's GPT, right? Like I'm on GPT Plus, paying my, and I do, because I'm a power user. I asked GPT, hey, where am I ranked in like users? And it's like, oh, you use GPT all the time. It's like, you're in the top 100,000. I'm like, there's 800 million users. There's no shot that's true, that I'm in the top 100,000 of 800 million. And it turns out it gives the same answer to everybody, actually. Which sort of like worries me a little bit for, is it hallucinating all of the advice that it gives me? But what I'm doing is I'm generating basically a textual string that gets sent out over a wireless network. As you know, that's data sipping. Then the inference happens somewhere, and when it's a string back, that's not a lot of data actually. However, that's not where it's going. Where it's going is images and video. And if all of a sudden, and by the way, it's like the outputs are not like optimized in the same way that like YouTube codecs are very good and Netflix codecs are very good at delivering a 1080p experience at like, just a fraction of the data that it cost years ago. When you get a video from like ChatGPT, and I'm sure they'll get better at this over time, but it's not optimized in that way. Consequently, all of which is to say that when I'm getting data on the downlink, that's video, all of a sudden there's a much more intensive data demand. And then I'm going to start sending video on the uplink, And again, I want something analyzed. I want them to respond to some kind of, news article or something. What is this? Can you tell me what this is? So just in terms of data management, it does become an issue, right? It will quickly become an issue. I'm not saying it's going to swamp or overwhelm our networks. Y'all are very good at this. But I do think that just continuing to deliver a really good UE experience, you're going to need to enable AI with Spectrum, going to need to enable AI with further network build out, further wireline build out. And yeah, it's going to become a challenge for sure.
Well, and your agency, is this working? Yes. And your agency will play a major role in that, obviously, with spectrum policy, with federal spending, with permitting policy, et cetera. And we appreciate the focus that you're putting on that. You mentioned ChatGPT. Apparently you're a power user. Is that what you said?
That's what ChatGPT says. I'm not sure that that's true.
Okay, that's cool. Besides sort of, and you mentioned sort of the textual usage of it today, as you sort of talk to different business leaders and do your own research at the agency, are there other ways that wireless infrastructure will enable new types of AI applications? Like what other kind of applications are you thinking about?
Yeah, so eventually we are going to all be driven around by like driverless Waymos, right? That's not today, but that's soon. So you can
think that's soon?
Yeah, I do. I like soon as in measurable in decades. What I will say is I don't mean decades plural. I mean within a decade. That's my.
Have you been in one?
Sure. Yeah.
Oh, nice.
Yeah. And it's cool and it's a little weird, but I think that the long pole of the tent is, and I just sort of heard this on the way out from ARPAN, is it's going to be regulation and culture. I talked to my mom about this, and I was like, Mom, like, eventually I'm going to buy you one of these things. She's like, because she was like, the Powerball I think was recently like $1 billion or whatever, And she said, if I won that, like I'd get a driver. That'd be great. I was like, well, we can get you a driver. It's not going to cost $1 billion. Like, we can just get you a driverless car. And she's like, ain't no way. And I was like, Mom, first of all, I know, I've seen you drive recently. Like, it's definitely safer than you. I don't know if it's safer than average, but it is an absolute improvement over status quo ante.
All driverless cars in Florida, 2026.
Yeah. There's a good South Park episode called Gray Dawn that I advise you all to check out if you haven't seen it. It's about this very topic. Anyway, so you can do a lot of info, and you see like Waymo's got the little thing that's like, their radar system. They're doing radar, LiDAR, synthetic aperture radar. It's a lot of data, actually. It's a ton of data. And you can do a lot of that inference because the car is pretty big. So you can do a lot of the inference there. But when it comes to like orchestrating large fleets, right, within an urban environment, eventually you're going to have to push some of the inference to the edge, right? And so this is still very urban, but like, you have some kind of like utility pylon that has, some network equipment in it and some antennas in it and so on, but it has the ability to push out the computer. And why is it important to have it here as opposed to some data center somewhere? It's a situation where milliseconds matter, where probably microseconds matter, right? And that's going to be really, really, really important. And that is going to be, and that's not just going to enable the orchestration of fleets of vehicles, though it will, like maybe that's how we manage drones. Like there are, and frankly, like just getting the spectral environment right in urban areas to possibilize all of this stuff is going to be monster investment, as you all know. And so, yeah, I think that's going to be, again, the sort of bricklaying level of AI that telecom provides is going to be really, really important.
Don't mind if I blow glasses on to you.
Oh, there you go.
Is this cool? Do I look good?
I'm reserving time on that.
Well, you don't mind if I stream this, do you, right now?
That's fine.
I can stream it live to my mom on WhatsApp?
Go for it.
Awesome.
Hi, Mom.
I actually do stream things live to my mom on WhatsApp using these glasses. And I feel really weird right now, but I'm going to go with it. So, she lives in Florida. We should talk about your ideas. Mm-hmm. And she can't watch her grandson play soccer, right? But she can now because I put these Meta AI glasses on. I click a couple buttons, and she's literally seeing what I'm seeing, and I don't have to be that guy. Sorry. And you don't want to hold the phone up, right? You just want to watch. And so she's now watching the game through my eyes. That's pretty cool. I don't know if John's still here from Qualcomm, but hey, John, they organized a meeting for me with some of their leadership in San Diego at their headquarters. And I was meeting with the head of research who was working on 6G standards and whatnot. And he was explaining how he had just been in Spain, was in a museum, didn't know any Spanish, and all of it was in Spanish. And he just asks it, what does this say? Right? And now he's able to just, boom, seamlessly participate as if he was a native Spanish speaker. That's pretty cool. The one that got me the most, though, was an application for the visually impaired. And the way it's working now is the blind individual puts these glasses on. Can't see any better with the glasses. However, somebody can see for them. And so the app that they're using now is they do the same thing like I do with my mom, and they can have a human tell them, hey, 2 more blocks, take a right, take a left, watch out, there's a crazy motorcycle coming at you, whatever. And that's great. But if you think about the next version of that, it's not going to be a human. It's just going to be the glasses telling them. And that will have a profound impact on our network. It's think about that. That is me streaming for 90 straight minutes of a soccer game or upload the whole time, right? And that's just one application. Like, I don't know whose example it was earlier about, maybe it was you, John, talking about planning for your vacation. These things just multiply. There's just so many different applications, which I think is it's just a really important thing to think about. Now I'm going to take these off. All right. And do you think that there's an appreciation for the infrastructure needs that go with that? I don't remember who it was on the prior panel, but it was basically that people think of it more as a software issue. Like within NTIA, within the administration, do you think there's an appreciation in general among policymakers about the infrastructure side of it?
Yeah, I think there is. And I think there certainly has to be. The question is just, which infrastructure, right? And I think it's going to be both and. We are going to need for ubiquitous AI for the reasons that you've just mentioned, ubiquitous data infrastructure. So it's not that we need more wireless, and it's not that we need more wireline, and it's not that we need more LEO, and it's not that we need more licensed, and it's not that we need more unlicensed. We need more all of it. And in fact, the only way that we're going to get there is through the usage of AI itself. There's going to come a time where, we're trying to figure out, how to like orchestrate frames at the edge of a band, or how to figure out, what the size of a particular guard band should be. So like in other words, spectral densification. So taking it to the spectrum side of the house. And we're going to need AI to solve a few of those problems, right? We're going to need, frankly, at NTIA, when it comes to just, and this isn't like really your guys' issue, because I gather probably most of you are either playing in the licensed space, or if you're in the unlicensed space, you're in like a couple of like well-known unlicensed bands. But if for whatever reason you're trying to use federal spectrum, right? So coordination with the federal equities, we should really be using AI a lot more for something like that. And if we can get that right, where else can we get it right? But it is definitely going to be, we're going to need to blow the doors wide open. And it's a non-trivial challenge. And you guys know this. And, and how, like, there's only so much of it. There are physical limitations. So here is hoping that in the future, AI can help us think through the best way to sort of share. Like, we think of sharing in terms of physical separation or time separation, but what about when everyone is using all of the spectrum all of the time? What do we do there? And for instance, when you guys look at like a propagation map, right? This is fundamentally two-dimensional or that's the way that we've thought about it historically. But the spectral environment is three-dimensional. In fact, it's four-dimensional. But for the purposes, for instance, of sharing a physical space, forming beams, so on, it's three-dimensional. What if I have like a point-to-point link, like I'm powering internet in that building and you're over here powering internet in that building? And ordinarily, that would be a very difficult situation for us if we're operating in the, but what if we're very good at beam forming and my beam is up here and your beam is down there? And we can find a way to make that work. AI, like I said, in terms of the air interface, especially in 6G, I think is going to be very helpful in these things, but it's going to require a lot of very thoughtful thinking that's definitely not anything that I can do. So good luck to you all.
All right. We talked about different use cases that are going to be, we think, coming because of 6G. Things like non-traditional network integration, satellite technology, Internet of Things improvements, integrated sensing and communications, or ISAC. And I think you just touched on this, but maybe just a little bit more about how AI plays a role in all of these different types of things.
Yeah. So I'd like to drill in on ISAC for a second. I don't know what the commercial application of that is, but let's say that you figure something out. That's going to be a spectrum monster. Like, just especially like if you're doing like real-time mapping using ISAC functionality from like a RAN somewhere. And I don't know what you're using that for. Maybe you're using that to map a spectral environment. Maybe you're doing like spectral sensing. Maybe you're doing actual physical sensing, which you can do. I don't know what that looks like, but I do know that is going to require a lot of like bandwidth and a lot of just like, that's going to be big. So, you know, I don't know how that winds up working. What I could say is, I think in general, like with IoT, so rolling the clock back to 5G a little bit. 5G is a very cool standard, but it is fundamentally, it is in many ways an industrial control standard. Like ultra low latency is not something that is like consumer UE for the most part, but it definitely is for industrial control, right? As we move into further advancements in wireless technology, especially utilizing some of the native security features that are going to come baked in to 6G, again, and we're anticipating AI enabled, what kind of non-consumer applications can we get out of that, especially in the IoT space? How can we utilize the latency, the very good latency characteristics, the very good security characteristics to potentially operate industrial private networks? Like we still can do that with 5G. That's not a missed opportunity or anything. We should be running toward that. But I do think that 6G provides potentially with sort of AI-driven network management, sort of native, hopefully just greater automation. And I think we're going to need that, because I think we really want to start reshoring some capabilities here in manufacturing. Like that's a very important policy goal, I think, for everybody. And I think telecom has a major role to play there, wireless specifically.
On the first panel, on the, where we were talking more about the technical issues, one of the questions was what keeps you up at night, and the first response was cybersecurity. So when we look at 5G and the evolution to 6G and the conversation we're having around AI, is security something that NTIA is thinking a lot about?
I mean, I think it's something that everyone is thinking a lot about. It is, you know, I can say that there are many very intelligent people in USG that think about cybersecurity. And while we certainly do care about that, we sort of care about that in our limited telecom role. We reach out to interagency partners when it comes to that issue. What I will say, though, is as useful as AI will be in securing a network, it will be equally as useful in unsecuring a network. And I don't know what that sort of arms race is going to look like, but please be prepared. Like, you know, you only have to look to not too distant news to see how significant this question is. And it is something that, you know, we would just ask you to be as prepared for as you can be, and to take as seriously as you can, because people, you know, sort of sitting on my side of the table, take it very seriously. And when we get news about breaches, nobody, I can say this with confidence, nobody takes it very kindly. And it behooves you to keep us out of your hair by taking it at least as seriously as we will.
Fair enough. Okay, last question to wrap things up. Just big picture. One of the things that the WIA team has talked about a lot is the sort of main word we heard under the prior administration in sort of the telecom space was broadband, right? Internet for all. right? Of course, this administration is still focused on internet for all and getting everybody connected, but clearly there's a focus coming out of the White House on artificial intelligence. And that sort of culminated in the release of the president's artificial intelligence action plan, which has a lot of important aspects to it. I would point you to Pillar 2. It's my favorite. It's about infrastructure. But from where you sit at NTIA, what is your role in administering the president's AI action plan?
So we actually have a few specifically designated remits, which maybe won't be entirely thrilling to all of you, which are open weight and open source models. We care a lot about the adoption of those. We do care a lot about helping small and medium enterprises adopt and use AI. We focus up on drones and the sort of drone supply chain. We are working on that because that has a very large spectrum component. And we do a lot of the work in sort of international advocacy around AI. While that is a variety of folks do that as well, certainly at least as it relates to telecom, we do some of that. So that is where we have been designated to play. But what I can say is, well, a couple of things. Number one, we are also admonished in the AI action plan, and this isn't just NTIA, this is literally all of USG, to be using AI in our own lives, in our own work lives, right? And we're working to integrate that into the most sort of fundamental functions of NTIA in spectrum management. We care a lot about that issue. And I can say that, we want to play a sort of, I don't know, a convener where it makes sense for folks in telecom specifically to come and say, like, if you have notions around how commerce specifically or USG broadly can or should be thinking about AI in the telecom space, come to us and let us route you there. So we aren't like the lead AI agency. In fact, I think it's interesting to imagine that there would be such a thing. I doubt that will ever come to fruition, simply because that's like saying, like what is the agency of, like, I don't know, the air that we breathe? Well, I guess the EPA. What I've kind of said something deeply, profoundly stupid, and we're close to the end. So that's what you're going to leave with in your minds. What I mean is everybody breathes. And so, I think AI is going to be totally ubiquitous in life, right? And so how do we think about AI? I guess we think about AI as one of a variety of technological and physical tools that any individual agency may use, and consequently, I think we adapt our existing regulations, our existing norms, our existing policies to accommodate AI within our remit, right? So I think that's largely how NTIA is thinking about it, undergoing an evolution that accommodates AI within the sort of domain in which we already play.
Excellent. And that's an important role that you guys play with spectrum policy, infrastructure policy, federal broadband spending policy, just broader internet governance and international coordination. The work that you and your team does is extremely important. We appreciate it. We value, WIA certainly does, and I'm sure I can speak on behalf of all of our members. We value the work that you individually and the rest of your team does. So thank you in general, and thank you for being here today. Round of applause for Adam. All right. Thank you, sir. Appreciate it. Absolutely. All right. And I think it says I'm going to offer concluding remarks, so I'm going to do that right now in about 30 seconds. So first of all, thank you to Verizon. Round of applause for Verizon for this great facility. And to our sponsors, of course, we can't do these events without you, so thank you very much. I'll just conclude by saying I hope you all heard what Mike Saperstein, my distinguished colleague, said earlier, which is if you learn nothing else today, go home with the thought that wireless infrastructure is AI infrastructure. We are having extremely important conversations in this town and every town across the United States and globally, frankly, about the future of AI and what it means for our industries and what it means for us as consumers and businesses. And we are necessarily focused on the core of what that is, which is the data centers and the power issues, power sector, and all of those important discussions. But the vast majority of search is happening on your smartphone. And the vast majority of AI computation over time is going to happen increasingly at the edge of the network. It's just inevitable. That's just how it works for every technological advancement. So it's critically important that we focus also on the wireless infrastructure aspect of artificial intelligence. And I include spectrum in that, right? We have led the world in 4G and 5G, but it wasn't by accident. We have the world's most capable technology companies in this country. And there's no doubt in my mind that they are going to keep investing and they're going to keep innovating and they're going to keep coming up with incredible things that we haven't even thought of. And the most important thing we can do here in Washington and across state capitals is make sure that we're empowering them by putting the right policy frameworks in place that make what they do possible and get out of their way. So that we don't slow things down. And so as we go forward, let's be very thoughtful about spectrum policy. Let's be very thoughtful about infrastructure policy. Let's be very thoughtful about federal spending when it really comes to these things and how we regulate our sector in general so that we can continue to lead the world in wireless. And as I said, wireless infrastructure is AI infrastructure. Thank you all very much for being here.